with the module number 3, and we'll continue from there. So module 3, core solutions in Azure. So this is again a continuation part from what we discussed in the last session, but in a little different perspective. So here we'll now take a look on these. So the overall module is about these. Typically, we're going to learn about the IoT sphere in Azure. We'll learn about Synapse Analytics to Databricks, and then Azure Artificial Intelligence and Machine Learning Services, what offerings they give you, versus the management tools in Azure, which could be like the Azure portal, the PowerShell commands, command line interfaces which you have, or a tool like an Azure Advisor, Azure Monitor, or Azure Service Health, what those are and why those are, we'll get an answer for that. Now Azure Solutions, the first one. So we'll now learn about these, an understanding on the term called what is IoT Hub or Internet of Things Hub, IoT Central, Azure Sphere, Synapse Analytics in Azure, HD Insights, Databricks, Azure Machine Learning Services, Cognitive Services, Azure Bot Services, and then Azure Functions, Azure Logic Apps or DevOps, GitHub, GitHub Actions, and Azure Dev Test Labs. These are something we'll be touch basing now. The first one, Azure Internet of Things. So in a simple word, what is that Internet of Things? Most of you might know this. If not, in a simple word, today you can see most of the devices are controlled in the means of internet. Like you can turn off the air conditioning system in your home by using a mobile device if you have a proper connectivity of internet for your AC system. You can start your car with your mobile phone, turn on the AC in your car, or lock your car sitting in your home with your mobile phone, and which means something is happening with your electronic gadgets without you physically going there, and that's been done by a tool or a technology which is called IoT or Internet of Things. What exactly it is? It's a concept where there are plenty of available components in the market which are nothing but computers, but not like a computer that we have with a display screen and etc., but a computer that can understand your information, process it, and make certain physical or logical or virtual activities to trigger. So that's what your IoT is. To make it more simple, in a simple word, it's a device that will receive your instructions where with any mode of input. It could be like a voice control you give, like open the door, close the door. You talk to your car and your car opens those, or you come to your home and with your AI system you talk, you say that open the door, and whatever you say, it's a text, or let's say it's a speech you're giving. So the speech is taken, understood by artificial intelligence, and it is converted into some meaningful information that could be understood by a microcontroller device, which you can say like Internet of Things, which is a kind of, let's say, a motherboard or anything. There are examples like you have Raspberry Pi, you have other tools which are in the market, like plenty of tools like Proton, you have various other things, but I mostly work on Raspberry Pi. So typically it's a device which you can program to make things work in it, or let's say applications work in it, where, as I said, you speak to your microphone and your microphone will understand your voice, and it will process the voice to some meaningful information that my IoT device can understand, where it will now trigger some electronic signals, where a physical device could be like a motor that will run and open your door, or a motor that will run and close your door, or it could be like a logical process where you say to start your or turn on your air conditioner, where your information which you said now is taken by your IoT device, and it process the information and give the instructions to the devices like your air conditioner, where there could be some of the relays and all which will listen to the instructions from the IoT device and turn your AC on and set the air conditioning temperature according to your wish. That's a simple example. Now you see plenty of examples you have in front of you. You think about the washing machines, like one of the examples, Life's Good washing machine, the company of LG. So what they do, they embed IoT devices in the high-end models of their washing machines, where there is zero maintenance for an end customer, which means they use some devices in their washing machines. They collect the data about the washing machine health, how it is working, how long it is working, and then how they are basically working for you, or how the incoming data which speaks about like how many days once the washing machine is used by the customers, or all these kind of information. All these, it's basically generated by some sensors. It's been collected from the washing machine. And just give me a minute.
This
Kind of issue with the
conference will
team.
now be recorded.
Okay, that's just a technical part. Sorry for that. We had some issue with the GoToMeeting tool, so just stop for a moment. I think now we can proceed. Okay, now getting back. So now how your IoT device is working in here is pretty simple. It is gathering all these information with some sensors, which could take the details like how often the machine is used, at what temperature the machine is working, is there any malfunction, all such data the sensors collect. So when sensor is collecting the data, it cannot keep with it. It should give it to someone. So that someone is going to be a cloud platform which can process the data, but there should be a broker who takes this and gives somewhere, and that is where your IoT device comes to the line as a computer, which will take this data from sensors, send that to the cloud platform, which could be used for later analysis. Like I said, your team of LG will contact you saying that we need to service your washing machine on a particular cycle, or maybe some problem happens, they themselves come to your location without you calling them. Which means here they see your data and dashboards and they come to a conclusion, okay, there is an issue and I think I should work on this. The team knows that, and they schedule an appointment with you on your availability. They come to your home and they work on your device. And that's a very simple example of Internet of Things. Now, why am I speaking about that? Now, that's where the major factor comes. Now, anyhow, anybody can purchase a device. If you see, I have a device called Raspberry Pi with me. I do a lot of programmings in it, which I can use it for a lot of automations in my home. Now, the point is anybody can purchase such devices and use it. But for building an enterprise grade solution, you have plenty of components in cloud platform. And that's what we are seeing now. The first one is called Azure IoT Central. What is an IoT Central? It's a management tool given by Microsoft Azure. Now think an example. LG, they are having plenty of washing machines they would have sold to customers across the globe, and each and every washing machine might have an IoT device running in it. Now, how do you manage them? How do you control them? So you need a particular environment that could help you to deal with some management, some monitoring, some activities of, let's say, scaling the performance or anything. So that's where IoT Central is a software as a solution that Microsoft has built. Where using this, you can manage your IoT devices so that your ability could be advanced. So now Life's Good can focus only on developing the washing machines and making the IoTs to gather the details rather than building a solution on managing the IoT device separately. So that's one of the tool, which is Azure IoT Central, that could help you to monitor and do management of your IoT devices across the globe. Next one, you have IoT Hub on the other part. Let's say IoT Hub, what could be this part? Now, your IoT device, which is running in your washing machine, as an example, I said, it's collecting all the data from the washing machine and it should send to the team of Life's Good to see the monitoring part. So now there should be a broker in between who will take the messages from this device and deliver that message to any cloud services that could be used for visualization and analysis of the data. So IoT Hub is a simple solution that could act like a broker or a piece of solution that could collect and connect with multiple, let's say, millions of IoT devices, send and receive data to those devices, and get the data from those devices to your applications or services in cloud. So that's what IoT Hub for you. So solution, is my voice breaking for everyone? And I don't think so. The GoToMeeting is saying that my voice is clear. Hmm, okay, maybe I'll try to do one thing. Let me rejoin. But yeah, in the GoToMeeting, the audio says like it's perfectly clear. Maybe. Okay, I'll try to just go slow. I'm not sure if that is an issue with the tool itself. Let me try to rejoin. Just give me a minute. Cloud
This
platforms.
conference will now be
And then,
recorded.
and the next one is your Azure Sphere on the other part. So when you say the term Azure Sphere, It's again like when you speak about edge devices, that's your IoT devices, security becomes very important. So your particular Azure Sphere is again an application-based solution that's built by Microsoft that could help you to securely connect and collaborate with your devices across the globe. So in a simple word, it's for security management for your IoT devices, a solution from Azure platform named Azure Sphere. So this way, for a geek who's working on IoT, Azure is giving these solutions in which you can play in. Maybe later I'll walk you through, let me complete the theoretical part, a demo on how do you create IoT Hub. And after you create it through IoT Hub, if say for example an IoT device that is sending a lot of messages, let's say some telemetrical data which is collected by an IoT device from a location like temperature and etc. How do you send the data through an IoT hub, which is registered an IoT hub service, which is typically taking the data from an IoT device. I'll walk you through that with a simulator that we have, or maybe I'll later show you. Same way, once you collect the data from IoT device, now take the example, the same thing. When your IoT devices are sending the data, they might send the data from each washing machine, let's say 3 times a day, or maybe like 1 hour a day, on millions of IoT devices and millions of washing machines, then millions of data you get. So data cleaning, data analysis for understanding the scenario is important. So that's where you can bring big data and analysis as an option as well. So in Azure for big data, you have solutions like, let's say, Azure Synapse Analytics. So it's a warehouse solution from Microsoft, which can be used for data modeling and designing, specifically for any relational database or NoSQL database. You can use this Azure Synapse Analytics, where you can take your data, execute complex queries over your data, model your data to do some trend analysis. Like I said, now your IoT devices send a lot of data. In that, I'll take some of the data that speaks about how often my team of LG goes to the customer location to go and make the particular devices like the washing machines to work properly, like the malfunctions I'm speaking about. Now that's where your team comes to the line where they make a data analysis, like for the last few years, how often the team have went, like every year, is that increasing the number of times the team goes to the customer and repair the machines, or it's decreasing in the count. So you come to a trend analysis, which is something you can do by using the Synapse Analytics as a data modeling. Same way, HD Insights you have, again, it's based on the open source solutions like Hadoop. So if you need a solution for, let's say, doing some big data queries, where that's a NoSQL database and you need an open source tool like Hadoop, Azure offers a service called Azure HD Insight, using which you can execute all your big data queries over your data. Same again, any lot of data that comes from the IoT devices. So to process it and come to a conclusion, like what is the major problem that's happening in my device. I can't read the millions of data sets and understand the reason, but I can filter my data, query, and come to right understanding, which you can do by using Hadoop, which is an option as HD Insights in here. Databricks, you have the Azure Databricks. So it's again based on the Apache Spark based querying tool. So it's again an analytical querying engine. So based on open source option, which is Databricks, Azure offers you a tool called Azure Databricks, which could again be used for big data analytical querying, where Azure virtual machines will parallelly work for you for executing the query. So in a simple word, for big data querying and then analytical querying, so for big data, you can use Synapse Analytics or HD Insights, whereas for analytical querying, you have Azure Databricks as solutions for you. Again, for AI and machine learning services, if you're thinking about, let's say in Azure, what option do I have for an artificial intelligence and a machine learning solution? So we have Azure Machine Learning option. It's a service called Azure Machine Learning Studio, or let's say Azure Machine Learning, where you can develop a machine learning algorithm or you can develop a machine learning model, then train that with the knowledge and then deploy that as a service. In a simple word, so there are plenty of algorithms. You have regression algorithms, you have elliptical curve methodology of algorithms. In a simple word, various algorithms you have, or you can even develop your own algorithm, which means what is an algorithm? Mathematically, it's a term which will define how an execution works. Same thing in here. So in a regression algorithm, you take it, which means regressively you're dealing with some activity in mathematical problems. So here, in a simple concept, it's all about some mathematical algorithms defined and kept ready, or you build your own algorithm like that. Now let's say I'll take an example of the same one, the regression algorithm, which will recursively understand a picture and understand what exactly the component it has in the picture. So you take your example of your mobile phone. So in your mobile phone, you have the face recognition option, which means whenever you just open your mobile device and it see your face, it will unlock the mobile phone. And how does it do that? For the first time, when I plan my settings in my mobile phone, I provide my face as an option where this is the face you should recognize and unlock the device, which means that is where the team has developed a regression algorithm based on some face recognition, where it will recursively understand your face when you show it for the first time, and it will train the API with the knowledge, and now it's deployed as a face API in your mobile phone. So whenever you open your mobile device and show your face, with the knowledge that the API of face recognition has with it, it is going to recognize you and unlock your phone. Now that's an example. Now, in case you want to build such kind of solutions, you cannot directly start with, which means you should start with machine learning to make your machine to learn what you're trying to do. So that's how today the face recognition APIs, or it could be speech synthesis APIs, or it's like text to speech conversion APIs, or any AI solutions you see today. It's something they build using these kind of technology, where in Azure, for building such solutions, Microsoft offers you a tool called Azure Machine Learning. Next one, you have cognitive services on the other part. So again, when you want to build a solution or an API of AI on your own, you go for machine learning solution of Azure. Same way, if I want to use, let's say, the face recognition API, which I said now, what if I want Microsoft to build an API like that, an algorithm like that, and give it to me, or I can just train the API to understand my faces and understand who the person is. Then that's where Azure offers you a term called cognitive services, in which you have hundreds of APIs, like APIs that can understand text, APIs that can understand what you speak, API that can convert your speech to text or text to speech, API that can recognize you, API that can analyze a video for racial content, APIs that can read a text data and find the sentiment of a user. So plenty of these kind of APIs you have. So a completely built machine learning solution which is sold as a service, that's your cognitive service. So these are like, plenty of options you have which you can use it. So this is like a built API which you can use and pay money for what you're using. So face recognition you want to do, you have. So there are choices like that. Next one is Azure bot service. The bot service, if you go for this one, so for you, you need to focus on a concept of development of a bot. What do? You focus on writing the framework from the scratch. So today, what Microsoft is doing, they're helping you to develop a bot by just giving it some knowledge and the development of the particular framework, management of the framework, and all these Microsoft is providing for you. So you can focus on feeding your bot with the knowledge, so that a bot with some enterprise grade level information could work for you. And that's what an Azure bot service, which you can achieve on in the line and play with people. So that's your bot service in Azure. So this way, for AI and machine learning, they have such options. Whereas for serverless computing, which means any execution of jobs or APIs you want to do, where the RAM and CPU core, I don't want to manage it. On demand, I need one CPU core and 100 CPU cores. They should get allocated, and when the job is over, the management configuration, all these should become automated, and that's where you go for the serverless computing concept. For that, you have two things. Let's say number one is Azure Functions. It's an event-based solution where a developer can write any program in it on Python, or it could be on .NET or PowerShell console or anything, where it's going to run for you on demand, which could be like manually you run this, or through some trigger or through some API call you run this, where one user comes into the line, the amount of RAM and CPU core needed for one user will be given, or 1 million users come to the line, then the resources that are required for the user is given, and that's something automated for you. Yes, Neha, Azure function is equivalent to Lambda and AWS. Now, a simple example, let's say you want to have some background jobs running in your website, which should not disturb your website. Let's say any customer comes to my website, like an insurance company website it is, to download their insurance copies. They can download it, but they really don't have to come and flood my website, because if I have my API of downloading an invoice in the website, then the CPU core and RAM of the website is also being consumed by those millions of users who try to download your invoice. Now, what if you think about an architecture like this, where your website will be running in the web server, but your API, that is a piece of program that could let users to download their invoice, I'll maintain it as a separate service like an Azure function. So whenever he makes a request to download the invoice, it calls Azure function. So the amount of RAM and CPU core required for one user or 1 million users is allocated automatically and they download the invoice. And that's where you can use Azure functions. So it's a serverless solution from Microsoft. Same way, you have Azure Logic Apps on the other part. What do you mean by the term Logic Apps? The term itself says you define logic in an application to work for you. So it's an orchestration service for automation, especially for non-developers who want to achieve some business-oriented activities, like integration between applications or enterprise integrations you want to do. For all that, Azure Logic Apps could be a right solution. Say, for example, you take this process. Now, I want to have a scenario where whenever somebody comes to my application and whenever signups with an account in my application, they should get a greeting email, which means the moment he signs up, I will call Logic App, which will take his details from the profile there and send a greeting email to him, which means now one user to 1 million users come. This will do the flow of sending a greeting email. Or let's say an example, every day by 7 p.m., the servers in my organization to be stopped, and every day by 7 a.m. they should be started. So Logic App can be defined with such a logic, and this could work for you in the given schedule of time. Manually, you can sort it, or in the given schedule, it should work for you, and that's what your Azure Logic Apps are. So to make it more precise, Logic App is same like your enterprise integration solution, which is like BizTalk server. Only difference is BizTalk is something that you use to manage your server scaling and all, but Logic App is serverless. So on demand, how much resources you require, that is your CPU core and RAM, you can get it, which is managed by Azure, and you pay money only for what you use. So those are your solutions. Now, for a developer who want to write some developer-oriented logics, go for Azure function. Non-developers who want to achieve some workflow orchestration, go for Logic Apps as a solution of option you can pick. Same way, I'll walk you through this, a demo on how do you deal with Azure function, a simple example on how Azure functions could be deployed and work with. I'll walk you through in the later part on the scene. Apart from those serverless services, what about the other components? So you can see we have some of the services like, let's say, DevOps solutions. So in Azure platform, we have Azure DevOps. What do you mean by that? So in case a developer requires a cloud-based solution for development-oriented activity, so Microsoft has a tool called Azure DevOps. So Azure DevOps is one place where you can build your programs, test your programs, compile them, and you can automate their building and testing and compilation, then do some vulnerability assessment, do load-based testing, and do work items planning, like who's doing what activity, which work is done, which is not yet done, set up some approver for deploying the code from testing to dev to production to anywhere if you prefer, which means it's a complete development oriented component which is called Azure DevOps, where you can do continuous integration and continuous delivery with a term called Azure pipelines, and plan your work items with a term called boards, and automate your performance related issues and test the performance information with a tool called load testing in there. So almost every component that a developer needs for collaboration and management you could achieve with the help of the Azure DevOps service. Next one, you do have GitHub. So DevOps is separate part, same way GitHub, which is the open source GitHub, which is now acquired by Microsoft, which is globally very famous tooling. Yes, you can use this one for any development source code maintenance, for version control, or it could be for task assignment to your team. So Azure DevOps also does the same. Difference is Azure DevOps has additional components like boards, pipelines, and plenty of other DevOps oriented components. Whereas GitHub also has your components, which could be like your code management and then pipelines, which could be planned and everything. But it's like mostly focusing on your source code management, whereas Azure DevOps is combined with source code management and developer oriented tools. Same way, you have GitHub Actions for Azure. So this is one I said. So if you want to integrate with your GitHub with some build and all these, like continuous integration, continuous testing, and deployment of the application, which is a source code hosted or written in GitHub environment. So for that, you can use GitHub Actions for Azure for integration. So it's like automated workflow management for continuous integration, testing, and deployment of your code, which is maintained in your GitHub. Again, the last component called Azure Dev Test Labs you have. So it's a simple, superb environment. Suppose you want to create some 10 servers with bot framework installed in it, Google Chrome installed in it, and let some users to use that as a lab server, or you want to deploy such kind of 1,000 servers for hosting some applications, then you can use Azure Dev Test Labs, where you can create an environment in prior with setting like what are all the components and settings that require in it. Which means, in a single word, you create a term called formula, a formula that defines what are all the components your VM or anything you deploy should have. And that formula, you deploy it, 1,000 times you deploy, you don't need to do that. You typically say, one time you deploy it, say that I want 1,000 VMs like this. Now, 1,000 VMs with whatever the formula you have written here will deploy for you on demand, which could help you to reduce your time where you spend on configuring the infrastructure and all these through GUI or through scripting. That's your Azure Dev Test Labs. Now, if suppose I need 10 servers to be deployed, where they should have bot framework, Google Chrome installed in it, .NET framework of 5. Whatever the new version of 5.0 comes, I want that to be installed and everything. No problem. You define a formula like that and keep it. Now, on demand, whenever you require that, just call the formula, deploy it, mention how many servers you need that, and it will create those for you, which is the benefit of this Azure Dev Test Labs inline. So these are some of the possibilities for services in Azure. Same way, for managing your Azure platform, you have these kind of components which I'll discuss next, the Azure management tools, where majorly we'll learn about Azure portal versus PowerShell versus command line interface, and then Cloud Shell and Azure mobile apps as well. And what is Azure Advisor? Why do you need that? What does mean by an ARM or Azure Resource Manager template? Then what is Azure Monitor? Why you require this? And service health in Azure will walk through. First one, to make it pretty simple, whatever you are doing in the Azure platform, deploying a VM it could be, deploying a web app it could be, anything. Sure, Lillian, I'll go more slowly. No worries, thanks for the info. Now, that is when you want to deploy any workload in cloud platform, you can use Azure Portal, the graphical user interface for management, deployment of the VM, DB, or anything. You have a mobile application from Microsoft. If you just check it in your App Store or Play Store, you find an app called Azure. We can use this for management of Azure resources, like let's say monitoring your workload, stopping the servers, starting the servers, checking some notification alerts, and such kind of things. You do have REST API calls which are supported. So if suppose you want to deploy a VM in Azure platform, you can use SDKs, or you can do direct REST API call to Azure platform to deploy resources, or you can write PowerShell commands, cross-platform command line interface commands, or you can even use a term called Azure Cloud Shell, an option that we have in Azure platform, where you can write your PowerShell or command line interface commands there to deploy and manage your workloads in cloud. So to make it more clear, anything you use, the GUI you are using, mobile application or code or script you are using, the deployment which you're going to make, that has been made as a REST API call to this environment called ARM or Azure Resource Manager. What is this Azure Resource Manager? It's a framework that is built by Microsoft to manage all the Azure resources. So if you create a VM, the virtual thing is what we see, but practically in the data center, there are various factors that happen for us. So those factor management, which means some controller and all these, that's what this ARM is managing for us. So we as end user, we make a call to this Azure Resource Manager, where it will now go and do all the background processings. Like if you want to create a VM, what must be done? You want to create a web app, what must be done? You want to create a virtual network, what must be done? Everything is controlled, managed, and deployed by this ARM, which is a framework of Azure. So again, regarding this, I'll walk you through a demo. That is, how do you create a virtual machine using the template, an ARM template, where what is this, how it works. When you use this ARM template, what actually happens in the background? to which environment REST API calls go and how do they work for you, I'll walk you through. I'll walk you through that later. Same way, we'll also walk you through on how do you create a virtual machine using PowerShell. So what is PowerShell is a big question most of you might have. I'll give an answer for that. Like how do you create some of the resources in Azure, let's say like a virtual machine, if suppose you want to create. How do you do that? By using PowerShell, by accessing your Azure subscription. How do you do that? And how do you see the performance or any other details regarding to the server using a tool called Azure Advisor? I'll walk you through. Same way, for people who have questions, why PowerShell? Why not something that I work on? Let's say terminal and Linux. For you people, you have cross-platform command line interface as well. So I'll walk you through this demo as well on how do you deal with cross-platform command line interface and then deploy resources in cloud platform, manage them, or deal with those services as well. And now, first of all, what is this term called Azure Advisor? You should know. So Azure Advisor, the name itself says it's advising for Azure services. At the end of the day, we people, we are just users, which means we people are just consumers or let's say customers for Azure platform. So we will know which is the best practice to deploy a resource. Eventually, when we start working with production workloads, we'll come to know. But in the initial phase you take, it's a big question. So that's where your Azure Advisor will help you to understand the best practices for each and every resource you deploy in the Azure platform and come up with an understanding information for you. So in a simple word, you have reliability. So whether your workloads you deployed are they reliable, which means is there any chance that it might fail, or do you have to configure a highly available architecture for backup and redundancy? So those kind of details it could give you, which is this part. Same way, security. Is there any vulnerability that you are introduced into your architecture? If yes, what is the best way you can sort the vulnerability? That's something you can find in the security. Your performance information again, whereas this speaks about the best performance details and all. So what could be done, whether you are using resources that are over provisioned or resources that are under provisioned, those information you can track here. Same way, cost optimization. So is there any best way that you can either increase little more pricing to get good performance or decrease your pricing by deleting or removing unwanted components? So those kind of things you get. Whereas the last one, which is your operational excellence, again, that speaks about apart from what you have, if there is some of the best suggestion, apart from what we have, if there is something which could be more better, which could be suggested. So that's something comes under this operational excellence. Using this one, you can come to know, okay, so this is some of the best architecture I have, so I can make it more better if I make a slight change like this. So that's something you can bring when you go for Azure Advisor. So Azure Advisor is like a suggestion which comes based on the best practices from Microsoft. Same way, you have a tool called Azure Monitor on the other part. Now there could be a big question like, am I using a server which is enough with RAM and CPU core that I have for my application to work? Or is my server is having more amount of RAM and CPU core which is really not required for my server to work? So sir, for such kind of questions, the answer could be given by your Azure Monitor. So your Azure Monitor, when you go for this is something that could help you to collect, analyze, and work with the telemetrical information of your servers, it could be, or diagnostic logs of your servers could be, or activities of your resources in Azure, it could be, or it could be even the logs, the diagnostic logs of your on-prem workloads. So one place where you can do complete monitoring, like if the RAM and CPU core is not enough for my server, I can see it in a chart or graph and understand, okay, this is not enough resource, I need to give more RAM and CPU core to my server. So such kind of analysis and understanding you can make in here. So here you can see Azure Application Insights you have, which is an option for doing an analysis for the performance of an application. Or log analytics, you have a tool for executing log level queries. Or you have smart alerts for sending up some alerts on demand. Like if CPU core of my server crosses 90%, I want to notify my team about the details. So we can use these alerts. Or Azure automation actions. So when your CPU consumption crosses 90%, rather than just notifying your team. What if an automation takes place where your server gets scaled out now automatically? So that's something you can do with this. Or customized dashboards, which are charts and graphs which you can see to understand the performance of one or more servers in one place to make them better. And all these you get from this single tool, which is your Azure Monitor. Same way, the Azure Service Health you have. What is this one? Now, it's not that every time that a VM you deploy, if it is not working, it could be your issue. Sometimes it could be an issue with Microsoft Azure as well, which means Azure might take their workloads for maintenance at particular date and time. So one of the tool is called Azure Service Health. It's available in Azure portal. If you search in the search box, you can find it. So services of Azure that are having issues, in particularly in which particular data center region it's not working, and when it was updated, and how long it might happen, and then explanation about what actually happened there, what is the impact, and what could be the time in which it will recover, and all such details you can find out in here, which means the services of Azure that are not working because of some maintenance that's done by Azure, or it could be like a planned maintenance or unplanned maintenance. Everything you can find in here to plan your work items, and you can see this particular link you can share with your team to make the team to understand. So this is the reason why the services are not working, and that's not the responsibility of, let's say, the customer, or it could be the developer team or an architecting team. So that way, an in-depth detailed report for management of the situation you can give to concerned authority, which could be given by this Azure Service Health. So now remember, these are some of possibilities you can use. Now see, this Azure Service Health, it gives you a detailed view about the particular service which is not working, in which region it is not working. Let's say communication regarding the outage, like why it was happened, which is the data center that's not working, whether when it has happened and when it is going to complete it, last update time, and which are all the subscriptions of you that are impacted if in case, and a tracking ID for it, and then followed by that a detailed information about, like whether it's a planned or unplanned maintenance which is done by Microsoft, and followed by that what could be the better outcome for this. All these you can track like this. Now again, your ARM template, which I said now, the ARM template, which I was discussing in a particular part. I mean, I didn't specify in depth about it, but if you remember in the last session when I deployed VM, I showed you a JSON script that defines your entire infrastructure, which you will deploy when you just make the create button to be clicked. So that JSON, which you will again see today, so that's ARM template you call it, which is a JavaScript object notation, where that JavaScript object notation is the file which we make as a REST API call to create any infrastructure in Azure. Suppose if we take ARM template, the resource manager template, then you write everything as one single script in a declarative way, and you make a REST API call to Azure Resource Manager, which will now make a REST API call to the resource providers of Azure, which are responsible for creating those VMs, databases, virtual network storage, and everything, and they will create it for you. So 1,000 times you repeat it, 1,000 times you get the same outcome. So there is an orchestrator to define what should be deployed first, and you can write it in a modular way where which resource you want to create, 1 or 10 or 100, and a built-in validation option as well. So which means like it will validate whichever the configuration you're creating is better or not. It will make a complete validation. If the script is wrong or your configuration you're defining is wrong, it will notify you before trying to make a deployment. And the entire script you can export as well. So once I create, I can export it into various other subscriptions of different other customers of Azure, redeploy the same architecture which is supported. Suppose you're not using an ARM template, then if you go for, let's say, infrastructure as a code concept, then in a simple word, you can use commands and you can make a put request and you make REST API calls or anything and deploy your resources, which could be done. An example, command line interface or PowerShell commands, or even your REST API calls you make through .NET SDK or Java SDKs. So using those as well, you can make a call to this Azure Resource Manager and deploy the resources. But everything, like VM you want to create, virtual network you want to create, disk of a VM, network interface of a VM. All these one by one you make as a REST API call. Whereas a resource manager template or an ARM template you can call, but this one is like the entire VM details like virtual machine, virtual network, and then your network interface card, disk of the VM. Everything is packed as one single component, which is one single script, and that script is being made as a REST API call to your resource manager for working. So that is the difference. So now you deploy 1,000 times, you deploy all components in it inside it 1,000 times, and if everything is fine, it deploys. If something is wrong, it just gets cancelled, which is the configuration. So that's a small walkthrough on this module 3, where we learned on the IoT hub, big data warehousing solutions we have, and then development tools like DevOps. And what is an ARM, Azure Resource Manager, and why it is. The monitoring tools like Azure Monitor, Advisor, Service Health, or ARM templates we walk through. So hope you get that. Welcome. Any other questions from anyone? Okay then. So first lab I'll be starting with, which is implementing an IoT hub. Then I'll show you how you create Azure functions. How do you create a VM using ARM template? Then creation of VM using PowerShell. Creation of VM using command line interface as well. So I mean, whatever I was speaking about in the presentation slides is the same labs. Let's say the first one, which is this one, implementing the IoT hub.